There it goes. Okay. So, your definition for a parabola, and this is your locus definition, is the set of all points equidistant from a focus to a directrix. Okay. Those are two more terms that y'all aren't familiar with when it comes to parabolas. But your focus and your directrix are super important. God bless you. All right. Now, we do know that a focal point, we have focal points in ellipses, right? There were two of them. We only have one focal point in a parabola. And if you were to highlight, I'm going to highlight this right here. This is our focus. And the focus is always located inside the parabolic curve. Okay? Always located inside the parabolic curve. Now, right here we have the vertex. And remember that the vertex is the, I guess you could kind of say, it's not the center, but that's where your axis of symmetry runs through. You build off of your vertex. It's the same on both sides. It starts to repeat. And then from that vertex, we have what is called a directrix. And a directrix is a line. And that distance from the vertex to the focus is always going to be the same as the perpendicular distance from the vertex to the directrix. So when you're looking at this and you see all these little dotted lines coming off of here, okay, this distance right here is always going to be the same. And then any point on the curve, that point is going to be the same distance to the focus as it is to the directrix. On around, this distance to the focus and directrix is going to be the same. On around up here, this distance and this distance are going to be the same. So that is the important part that you want to remember, and that is how this parabola is built. Now, that distance that I was talking about between the vertex and the focus, and the vertex and the directrix, this is a value, and we're going to call this P. Okay? And that distance is the same in both places, here and here. And P represents the distance from the vertex to the focus and directrix. And I want you to notice these ordered pairs right here, this ordered pair right here. If the vertex is at 0, 0, then the focus is at 0, P, whatever the P value is. And right down here, your directrix is the opposite of P. It's the negative in this case because we moved in a negative direction. And notice that the directrix is a linear, is a line, and it's horizontal, so it's going to be written in the form of y equals. All right. Those are your basics. Those are your basic things that you need to know about the parabola. Now, we're going to get that information from the standard form of a parabola, and we're going to have to be, we are going to be using completing the square to transform these equations from general form into standard form. Again, we have two different directions that these parabolas can go. We can have a vertical or a horizontal parabola. All right, now, because parabola quadratics are functions, okay, our vertical parabolas are considered functions, but our horizontal ones are not. And I want you to notice the difference in the equations. The y is squared in the horizontal, so it's going to be opening up sideways. It will be opening up like this, or a negative direction like this. And your vertical parabolas are going to open up upwards if it's positive, or downwards if it's negative. Your vertex is what your center is, you know, in your circle and your ellipses and such. But in this case, your vertex is the very middle. It's where you build off of. It's either your highest point or your lowest point if it's a vertical. All right, and then H and K represent your vertex. P is the distance from the vertex to the focus. I want you to look at this part right here. That part of the equation says 4P. The way this is set up is just a little bit different than what you're used to seeing in vertex form. But this is going to be a number, whatever number that is. And to find P, we're going to set that value equal to 4P and solve for P. So that's going to be important to get your equation set up in this standard form right here. Now, as far as the formula goes, and on your formula chart where it says how you can find your distance to your focal point, depending upon if it's horizontal or vertical, this makes my head hurt once again. I don't like this. I'm going to be looking at it when I look at my parabola and I see the direction that it opens. I know my focus is always inside of the parabola, always inside, and that my directrix is outside and it's a line. And that directrix is going to be a horizontal line if it's a vertical parabola, but if it's a horizontal parabola, it's going to be a vertical line that runs up and down. So these are little tendencies and things that you want to pick up on as you're working through it, and not focus on, oh, I got to memorize all of this stuff. No, you do not need to memorize all this stuff. It is literally just counting, just like it was in the ellipse. All right, so now then, one more term, and this is kind of a funny term. It is called your latus rectum. Okay, your latus rectum is a segment, and it's basically the distance between two sides of the parabolic curve. And your latus rectum always runs through the focal point. Okay, so right here, you've got your focal point, and this latus rectum goes from one side to the other. This is 4P. That length, whatever the 4P value is, that is the length. So that way you can very easily find points to graph your parabola. So all you need is your vertex, your focus, your latus rectum, and you can graph your parabolic curve. So since this entire distance across here is 4P, what I want you to identify is that this side of it has a length of 2P, and this side over here also has a length of 2P. So it's easy to divide it up, and then you can find the actual distance to plot your points to get the rest of your parabolic curve. And then this distance right here is 1P, and this distance right here is also 1P. So P is a very critical value in graphing this sucker. All right, so you've got your rectum and you've got your P. All right, so now make a note that the latus rectum, it runs through the focal point, through the focal point, and gives 2 more points to plot the curve. Okay, gives 2 more points to plot the curve. We're going to practice all this stuff. All right. And just like we did with the ellipses and circles, I've got your equation, and I've got a visual set up so that way we can kind of identify, God bless you, all the key features in our equation with what we have here in the graph. All right. So to start off, let's go ahead and label. Notice that the x is squared. Since that x is squared, we know we're going to have a vertical parabola. But I also want you to notice this negative out here, this negative coefficient. That's going to cause a reflection. So notice that it's vertical, but it is opening down. So these are some key aspects that we have to be able to identify. That -8 is your 4p. H is your x-coordinate of your vertex. K is your y-coordinate of your vertex. So we're going to note a vertical parabola because x is squared. When x is squared, it's going to be vertical. So that equals vertical. And the -4p means that it opens down. Okay.
So does that mean p as a value is -2?
P as a value could, yes it does, because you would set that equal to -8, and then you would solve for it that way. Yes, you got it. Okay, so your vertex then is at -1, +3. All right. And I'm going to identify that in red and identify my vertex right here with a V. And then the value of P, we know that 4P is equal to -8. Therefore, P is equal to a -2. Okay, this value right here, that tells us where to move. We're moving 2 units up and 2 units down. 2 units down to get to the focus because I know my focal point is inside my curve. That's what I want you to think about. That's what I want you to consider. Okay? So, since the focus is inside the curve, move 2 units down from the vertex. And since our vertex is located at -1, +3, I'm moving 2 units down, so that's going to affect the y-coordinate. And that will give me a point at -1, +1. And notice in the picture, that's where your focal point is. That's your focus right here. Okay, now I want to show you how to use the latus rectum to get or let's go ahead and do the directrix first, and then we'll get the latus rectum. So your directrix is outside of the curve. So it's going the opposite direction from the vertex. All right, so we've got directrix is outside the curve. So move 2 units up from the vertex. And so that's going to affect our y value. And since it's a horizontal line, we've got y is equal to 3 plus 2, or y equals 5. This is where our directrix is going to be located. And my directrix right here, I am going to highlight in green. Y equals 5. Okay, so we've got our vertex, we've got our focus, we've got our directrix. Now, to use our lattice rectum, this is what we're going to use to get the rest, to be able to graph our parabolic curve. We discovered that the lattice rectum has a length that equals 8. Okay? A length that equals 8. So what you're going to do is you're going to move half that distance to the left and half that distance to the right. So you're going to move 4 units in each direction from the focus. So here you are right here. You're going to move 1, 2, 3, 4. Booyah. Right there, you're on the parabolic curve. And you're going to move to the left. 1, 2, 3, 4. There you are again. Booyah. Right there on the parabolic curve. So that, folks, is your lattice rectum right there. And that's how you will get 2 more points so that you can create your curve. So when you go to graph this parabola, you are going to focus on your vertex, your focus, your lattice rectum, and your directrix. Those are the key points, key things that I need from you. All right. Now, let's practice that on the next page. Example 2. You are given the equation in standard form. Now, I want you to pay attention to what is squared. The y. So this is going to be, there you go, it's going to be horizontal. All right, now, because the y is squared, be very careful. This is your k value, right? All right. H is over here on this side, because H is with your x. And we've got 4p is negative again. So since it's negative, and we know it's horizontal, which direction is it going to open? To the left or to the right?
Left.
To the left. There you go. It's going to open up like this because of that negative value right there. Okay. Now, give me the vertex. What?
1, 2.
1, -2. There you go. Because you remember the signs are supposed to be subtraction in there, so it's actually a positive 1 that was put in there. So we're going to plot a point at 1, -2. And that's going to be my vertex right there. Kind of trying to color coordinate this a little bit just so things are easier to spot. Okay, now, focus. We set 4p equal to -8. P is equal to -2. Now, as far as this being positive and negative, a lot of students are like, well, how do I know if it's positive and negative and which way I'm moving? I don't want you to stress about that. I want you to be able to look at this and just know you're moving 2 units away from the vertex, period. And depending upon which way your parabola opens is the direction where your focus goes and where your directrix goes. So since this is opening in a negative direction, and we are going to have to move to the left for our focal point. So I'm going to subtract 2 from my x coordinate because my focal point will be over here because of the direction that we know that it has to open. So since my vertex is at 1, negative 2, I'm going to have to subtract 2 from the x coordinate, and that's going to give me the ordered pair negative 1, negative 2. And this is going to be my focal point. So negative 1, negative 2, or look at this situation. All you're doing is going 1, 2, boom, right there's my focus. If you can count, you can find that ordered pair. All right, the directrix. Now, our directrix is going to be a line. And I'm moving the opposite direction from my vertex. So I'm going to be moving 1, 2, this direction. It's going to be a vertical line. And now, just looking at this, what is the equation of it going to be? X equals 3. There you go. So our equation is x equals 3. I'm going to go ahead and color that. And then if you want the formula written down there on how that was found by adding 2. We do the exact opposite. We move the exact opposite direction from the focus. So that is 1 plus 2, 1 plus 2 equals x, if you want to look at it that way, or x equals 3, because this is a line, this is not an ordered pair. Then last but not least, the latus rectum, it has a length of 8. Length equals 8. So what I'm going to do is count 4 units both directions from the focus. Count 4 units both directions from the focus. So here we go. Here's our focus. So I'm going to go up 1, 2, 3, 4, and I'm going down 1, 2, 3, 4. Draw my curve, and you're done. But those are your key features that you've got to have, okay? Your latus rectum, your focus, your vertex, and your directrix. That was very easy to graph. When it comes down to it, it's very easy to graph. The only thing that we're really adding to this is that latus rectum and the directrix. But it's just all a matter of counting, okay? Example 3. This one, you've been given the equation in general form. Let's put it in standard form and then find the key features. So this is where we're going to do completing the square. Now, I want you to look at this. I'm going to zoom in on it for just a second. Notice you've only got one variable squared. If you've only got one variable squared, automatically that eliminates a circle and an ellipse, and we haven't studied hyperbolas yet, but it would eliminate hyperbolas, because one variable squared means it's just going to be a parabola. Now, is it going to be a horizontal or a vertical? You tell me. What is it going to be?
Horizontal.
Horizontal, there you go, because the y is squared, so it will not be a function. So that's why we know it's going to be horizontal. You're going to set this up. Now, we're not solving this. We are setting it up in its standard form. So the first thing, what should be the first thing we do in this situation? Yes, in this case, we don't just move the constant, we also have to move the x. We are not completing the square for the x because the x is not squared, okay? We're only completing the square for the y's. So you have y squared minus 10y plus, and we're going to leave our box for completing the square to get our c value, equals 27x minus 133. All right. Now, complete the square. What would go in this spot right here? 25. Good. 10 divided by 2 is 5. 5 squared is 25. And I just added 25 to the left side. So I had better add 25 to the right side. That was another mistake that I saw on completing the square. A lot of y'all forgot to add to the other side. All right. So now that we've got completing the square finished, let's go ahead and write this in terms of factors. So it'd be y minus 5 squared equals 27x minus 108. This is where it kind of gets a little snarky. We have to eliminate the coefficient in front of x as well. To write this in the correct format, the structure, let me go back here to this formula, okay? Do you see how we've got this 4p located in front of the x minus h? That's because they factored out the coefficient of x. That's where that number comes from. So right here, we're going to have to factor out 27. Now, 27 times what is 108?
3.
Close, 4. There we go. So we've got 27 parentheses x minus 4. And then we've got y minus 5 in parentheses squared on the left side. Now we have it in its standard form. You can see that this is a horizontal parabola. Again, because y is squared. Now, which way does it open, left or right? Right, because it's positive. So it's going to open up this direction. Now, here's my vertex, here's my focus, here's my directrix. I am just sketching that for a visual, so whenever I have to find these features, I know exactly what I have to do, which direction I have to move, the way I have to write my equation, that it's going to be a vertical line for my directrix. All right. And our vertex, where's our vertex located? 4, 5. Perfect. All right. Now then, before we can find our focus and directrix, let's go ahead and solve for P. So to find P, 4P is equal to 27. P is equal to 6 3/4. Yeah, it's an ugly number here. So what we're going to be doing is moving almost 7, but not quite, in each direction. So we're going to be moving left and right to get to our focus and our directrix. So which coordinate is being affected? The x. So to get to our focus, are we going to have to add 6 3/4 to move right, or subtract 6 3/4? We're adding because we're moving in a positive direction. Okay? So we are going to take that 4 and add 6 3/4 to it. So there you go. So you've got 10 3/4, comma, 5. That's where our focus is going to be. Our directrix is moving to the left. Since it's moving to the left, we're going to subtract. There you go. So 4 minus 6 3/4.
X equals -2 3/4.
There you go. X equals a -2 3/4. That's going to be our equation for our directrix. So there are our key features that we've got there. And if you had to graph this, what would be the distance through the focus of the latus rectum? 27. Yeah, we're not graphing that. Okay, we're not going to graph that. 27. Okay, so the main takeaway that you need from this on your parabolas, your key features are your directrix, your vertex, your focus, and your latus rectum. If you can get those key features, you are golden. All right, and we will stop.